Okay, in previous sections, we've talked about congruent triangles and figures. And if you'll remember, in order for two things to be congruent to each other, they have to be identical. So their angles had to be the same measure and their sides had to be the same measure. But there's also something called similar triangles. And with similar triangles, you can see we have the definition here for similar triangles. Their angles must be the exact same measure, but their sides are in proportion to each other. Now, if you were to put those sides over each other, the measures of those sides on top of each other like a ratio, that would be a common ratio. We would have the same thing throughout the figures. And we call that technically a scale factor. Now, I also want to draw your attention to the notation for similar triangles. It's just the little tilde without the equal sign underneath it for the congruence. Okay, now we had patterns for our congruent triangles, and we have patterns for our similar triangles also. If you'll remember, we had a whole bunch of different patterns for congruency. The only ones that did not work for congruency were angle, angle, angle. You didn't have that. And angle, side, side. So, but all the other patterns held for congruency. We have three patterns for similar triangles that are side, side, side. So, in that meaning that the sides are in proportion to each other. We have side, angle, side. So two sides in proportion to each other and one angle between them that is the exact same. And then we also have angle, angle similarity. So if our angles are the same, then the triangles are automatically proportional to each other, but they may not be congruent. So you have to be very careful and watch for that. All right, let's jump in and see exactly how this works and what all we're going to be doing with it. So here this says, which of the following pairs of triangles are similar? If the triangles are similar, explain why and state the correspondence. And I'll tell you that all of these triangles that we're going to be working with are similar. So we're going to figure out the pattern, and then we're also going to figure out our scale factor or our common ratio. So here we have two triangles, ABC and DEF, and they've told us that we have an angle of 35 degrees in each one, and we have an angle of 70 degrees in each one. That is angle-angle similarity. Obviously then D and A must be the exact same also, because remember, the interior of a triangle has to add up to be 180 degrees. So we have angle-angle similarity. Now, as far as the common ratio or the scale factor, we look to see what proportion our sides lie in. So here we have a side length of 2, and this corresponding side is a length of 3. So that would be a scale factor of 2/3. So if we knew what this side was, then we would also know what this side is, because they would have a proportion of 2/3, and so on and so forth. Here in our second set of triangles, we have, I went ahead and I've drawn out this flipped over triangle. I've turned it around and flipped it so that you can see the matching parts here. So now then we have angle E is congruent to angle A. We have also another angle here of the right triangle. So again, we could look at this several different ways. We could say this is angle, 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 or we could also look at it as side, angle, side, side, angle, side, because these sides are in proportion to one another. If we looked at the ratio of them, we could put matching parts over matching parts, so that would be 4/8, and that should be the exact same as 3/6, and it is. They're both 1/2. So both of those sides are in the ratio of 1/2 to each other. Let's look at a third example here. Here we have, again, two similar triangles, and we know that they're similar because we have matching sides. Now you may not know this, but these are two sides here that are cut by a transversal. So these sides are automatically in proportion to each other. Anytime you have a triangle that is cut up like this, it's automatically these lines being parallel are proportional to each other. So in this case, we have a side, an angle, and a side that is proportional to a side, an angle, and a side. So this is side, angle, side proportionality. Now, if we want to look at that ratio, we would need to compare common parts to common parts, and in this case we could compare this one side of the triangle. So for the smaller triangle, that would be a 6. For the larger triangle, we'd have to add both of these up, so that would have an entire side length of 8. And when we reduce that down, that would be 3/4. Or if you turned it upside down, then it would be the same thing. You could compare the larger triangle to the smaller triangle. Either way is acceptable. Now, finally over here we have these two triangles, and again we need to figure out if they're in the same proportion to each other. And in fact, these are. Now, they didn't tell us anything about the angles. However, we do know that because these are vertical angles, that they must be identical to each other. So that tells us that we have a proportional side, an angle, and a proportional side compared to a proportional side, an angle, and a proportional side. So this again is side, angle, side proportionality. And if we want to look at matching parts, well, we'd have to be very, very careful. So ABC is compatible or similar to angle DBC. So we would actually technically have to flip this second side over in order for it to match the other side. So that tells us that, and let me write that out, angle ABE is similar to angle or triangle DBC. So if we're looking at matching parts to matching parts, side AB would have to be similar or in proportion to side DB. So that would be 2/3 for our scale factor, or 2/3. Or again, we could do that upside down backwards, and then we would have the exact same thing, 3/2. You could also say it was in proportion that way. All right, let's look at another example. This one says, in the following figures, find the measure of the sides marked X. So for part A, we have two triangles, and again we have these two parallel lines here, so that means that this is automatically in proportion to each other. It's made it a smaller triangle and a larger triangle. And if we want to compare matching parts to each other, we could say side AB has to line up or be proportional with side AD. So that would be 5 compared to 10. And then on the other side, we could do the same thing. We could say AC would have to compare to AD. I'm sorry, AE rather. So AC would be compared to AE. So that must be in the same proportion as X is to X plus 7. And now we have a proportionality that we could set up and solve. So if we were to multiply 5 times x plus 7, that would be 5x plus 35, equals 10 times x would be 10x. And then simplifying this, if I moved my 5x over to the other side, I would have 35 equals 5x, dividing both sides by 5 to get x equals 7. So we just solved for x there using that proportionality. What about in this second set here? Here we have two triangles, and again it says they've given us that triangle ABC is proportional or is similar to triangle EDF. EDF. So we have to again be very careful about how we're setting up our proportionality, because it's not DEF, it's EDF. So let's look at our sides here. Let's look at, first of all, we have side AB, and that would have to be proportional to ED. So AB proportional to ED, that would be in the ratio of 3 to 7. That would equal, along this side we have BC would have to be proportional to DF. So that would be BC, which is X, in proportion to DF, which is 8, and now we have a proportionality that we can solve. So if I cross multiply, 3 times 8 would be 24, equals 7 times x is 7x, and then dividing both sides by 7, we get x equals 24 over 7. And that is okay. Remember, fractions are just fine. We don't have to worry about that. Everything can be fractions, and that's just fine. Okay, finally, our last example here says Samantha wants to know how far above the ground the top of a leaning flagpole is. At high noon, when the sun is almost directly overhead, the shadow cast by the pole is 7 feet long. Samantha holds a plumb bob with a string 3 feet long up to the flagpole and determines that the point of the plumb bob touches the ground 13 inches from the base of the flagpole. How far above the ground is the top of the pole? So luckily they've given us a drawing here. So she's put her plumb bob here, that's 3 feet long, and she determined that was 13 inches out from the base of the pole. She wants to know how tall the pole is, how far it is off the ground, or how far above the ground is the top of the pole. So she wants to know this side, but she knows that the entire length of the shadow is 7 feet. So we have similar triangles here that have been set up. Now, if we compare parts to parts, I'm looking for, say, that side, let's call it X. I could compare 3 feet to 13 inches, 3 feet to 13 inches, and that would be in comparison with X feet to 7 feet. Now there's a problem here. We're not comparing apples to apples. We're comparing feet to inches and feet to feet. So everything has to be in the same units before we can actually technically compare it. So what we need to do first is we need to change these inches into feet. Now, what you could do is you could say that they were, because we know that 12 inches in a foot, so we could say that that is 1 foot and 1 inch, and 1 inch is 1/12th of another foot. So we could label it as 1 and 1/12 feet. And then if we were to put those together, that would be 13/12 feet. Or you could just do it in the decimal form. So either way would be perfectly acceptable. But let's write up this proportion now. So we would have 3 feet compared to 13/12 equals X feet to 7 feet. And we can do that now because everything is in feet. So now if I were to cross multiply, I would have 3 times 7 is 21 equals 13/12 times x would be 13/12 x. And if I were to invert and multiply, because that's the best way to get rid of that, let me get my color going here. If I were to multiply both sides by 12 over 13, then that would cancel out my 13/12, and that would leave me with let me get my color going again here, x equals 12/13 times 21. So 12 divided by 13 times 21 is going to be about 19.38 feet.